Which celestial body in the solar system do we know the least about? On the surface of which object does the temperature approach absolute zero, where ice can take on fantastic forms? This is the dwarf Pluto, once expelled from the orderly row of planets in the solar system for not meeting the standards. The mysterious object is at an incredible distance from us, at its closest, 30 astronomical units away, and at its farthest, almost 50. That equals 4.4 billion kilometers and 7.4 billion kilometers. To understand just how far that is, you just need to realize that a year on Pluto lasts 2.5 centuries. Of course, optical studies of this extremely distant object are very difficult. So in 2006 from Cape Canaveral, the American spacecraft New Horizons was launched to Pluto aboard an Atlas V rocket. At the moment, this is the first and only automatic station in the history of space exploration to have studied the planet up close. Right now, New Horizons, following the Voyagers, is gradually leaving our star system. But before that, the probe managed to bring enormous benefits and an incredible amount of information. So, what did the automatic station see on Pluto and in its surroundings? The probe was given specific objectives, including mapping the surface of Pluto and Charon, its moon, studying the geology and morphology of these celestial bodies, investigating the possible atmosphere of Charon, spoiler, there isn't one, as well as Pluto's ionosphere, searching for a magnetic field on both objects. Did New Horizons accomplish its objectives? Absolutely. And it even exceeded scientists' expectations. The probe collected information that radically changed and significantly expanded our understanding of Pluto, which surprised astronomers who are decoding the data received from New Horizons. First of all, the voice of the planet. And secondly, the fact that Pluto actually has an atmosphere. Yes, it's thin and consists mainly of nitrogen, methane, and carbon, but it's the only trans-Neptunian object that can boast such a delicate gaseous haze. New Horizons was the first to photograph this haze during its flyby. Studies have shown that Pluto's atmosphere is about 300 kilometers thick and consists of a layer just 20 centimeters dense. Of course, the atmospheric pressure is almost imperceptible and extremely low. Unfortunately, the probe cannot be controlled manually due to the significant signal delay. Therefore, everything that New Horizons studied and photographed was programmed in advance. But it's still a breakthrough, because no spacecraft has ever passed so close to this celestial body, almost 12,500 kilometers from its surface. This period of the mission was fruitful. A lot of scientific data was collected, and that's at a speed of up to 4 kilobits per second. It took about 15 months to transmit all the information to Earth. Which features of Pluto's terrain especially interested scientists? First of all, it's Sputnik Planitia, located in the Tombaugh region according to New Horizons data. Its diameter is almost 1,500 kilometers, and its surface is relatively young and smooth. There isn't a single crater, although some astronomers believe that the plane itself is an ancient, enormous crater that was eventually filled with frozen gases. Another hypothesis about the formation of Sputnik Planitia suggests that after a large celestial body collided with Pluto, it broke through the icy crust and reached the subsurface ocean. Afterward, material from there rushed to the surface. Obviously, at a temperature of about minus 223 degrees Celsius. All of this quickly turned into a frozen surface, harder than diamond. In general, it is believed that without some kind of liquid substrate, such a vast plain would not be able to maintain its shape. This further suggests the possible presence of an ocean, a relatively warm body of water, due to Pluto's hot core. New Horizons, as part of the mission, studied the gravitational field of the dwarf planet. The data obtained also indicate the presence of a subsurface ocean about 100 kilometers deep, filled with water containing dissolved ammonia, which acts as an antifreeze. So, theoretically, it is possible to assume the presence of life in this body of water, of course at the microbial level. But to prove this would take decades, if not centuries. Are there really only plains on Pluto? Not at all. New Horizons showed images of the highest peaks, ridges, and entire mountain systems on the surface of the object. For example, the Tenzing Mountains, which border Sputnik Planitia from the southwest. They were first discovered by the mentioned probe, which then transmitted the data to Earth. The geological formation rises 3 kilometers from the base of the mountain. However, if we compare it to Everest, it rises almost 9 kilometers above sea level, but only 4.5 kilometers above the surface. The Tenzing Mountains can objectively be much higher, and New Horizons also discovered the Hillary Mountains, which soar a little more than 1.5 kilometers high. They are located to the south of Sputnik Planitia, so the rumors about Pluto's flat surface are greatly exaggerated. In addition, the probe photographed many different grooves, which further support the hypothesis of a subsurface reservoir, several plains, 6 mountain ranges, and a small number of craters. Of course, the list will be expanded over time. At the beginning, we mentioned the fantastic shapes and condition of the ice on Pluto. What does that mean on this planet? What is familiar are phenomena that shock Earthlings, like floating mountains. When a huge water iceberg floats in the no less dense nitrogen ice, no one would be surprised by drifts of carbon monoxide and methane ice covering the tops of the local mountains like caps. Ice on Pluto is a topic for a separate video, since such exotic crystalline structures are impossible on Earth and have properties that are difficult to understand. Among other things, the Automatic Interplanetary Station also paid attention to Pluto's largest moon. There are others, much smaller. Did you know that Charon is multicolored, with its surface dominated by snow-white, reddish, and brown areas? Where did the red color come from in this frozen world? Data from New Horizons suggests that the culprit is tholin molecules, which actively form when methane interacts with ultraviolet light. The Mordor spot looks especially bloody. Even its name gives you the chills. The probe photographed this structure on July 14, 2015. Indeed, the color of the Mordor Valley is strikingly different from the rest of Charon's surface. In general, this moon is much darker than Pluto, which may indicate a significant difference in composition. Mordor spot's diameter is 473 cm. It is located at the moon's north pole, and it might be an impact crater. How can we uncover the secret of Mordor on Charon? If the red color is explained by the presence of tholins, organic copolymers, then a similar area should also be present at the moon's south pole. If not, then we haven't uncovered this mystery yet. What is the main question that troubles astronomers when studying any celestial body? Was there, is there now, or could there be life on it in the future? In 2011, according to data from the Hubble telescope, complex hydrocarbons were detected in the spectral lines found around Pluto. From this, scientists concluded that there could hypothetically be simple life on the planet, but this microelement can also form without the involvement of living organisms. Are the harsh climatic conditions on Pluto likely to prevent any forms of life from appearing on its surface? Despite the fact that the dwarf planet is known for its harsh climate, Pluto even has tropics. The old meme about such a lousy summer immediately comes to mind. It's scary to imagine what the Plutonian Arctic must be like. Seriously though, these are just names that have little to do with temperature changes and are more about calculating the position of the sun in the planet's sky. For example, in the Arctic belt, which covers about 40% of Pluto's surface, in summer the sun doesn't set, and in winter it doesn't rise above the horizon, just like our polar day and night. The difference is that on this harsh planet, winter lasts about 60 years. By the way, on Pluto, there is a completely unimaginable climate zone for Earthlings called the tropical Arctic, where the characteristics of both zones are mixed. Of course, in Plutonian reality, this doesn't mean that frozen coconuts grow on palm trees or that there are snowdrifts on the beach. Will Pluto really remain icy and lifeless forever? Most likely no, because the characteristics of the solar system, although slowly, are changing. It is assumed that in about 7.5 billion years, the sun will begin to expand, and then conditions suitable for the development of organic matter may appear on the once dead planet. Moreover, our parent star may give Pluto tens of millions of years of tolerable existence until the sun turns into a white dwarf and almost goes out. During this time, life on Pluto may possibly develop into something intelligent. The 21st century is an amazing time, revealing many mysteries and secrets, as a result of which humanity begins to look at familiar things differently. Let's take our galaxy, the Milky Way, for example. Do we know everything about it? The Gaia Space Telescope has proven that we certainly do not. The orbital telescope not only accomplished its main task, creating the most accurate three-dimensional map of the distribution of stars in our galaxy and human history, but also uncovered an unpleasant secret about the Milky Way. How did our galaxy come into existence? How did it develop? And are there exoplanets in it? The Gaia telescope answered these questions with varying degrees of success before it was retired. All data from the observatory, and especially its interpretation, are beyond this video's scope. In addition, the information has not yet been fully deciphered by scientists. But the main thing we need to understand is that the Milky Way, during its existence, has repeatedly absorbed other galaxies. So does that mean our star cluster is a real cosmic bully? Most likely, yes. What evidence has the Gaia telescope found for this? In September 2018, it discovered substructures caused by gravitational disturbances from a collision with another relatively large object. Most likely it was a dwarf elliptical galaxy in Sagittarius. The object is called a satellite galaxy of the Milky Way because it orbits around it, just as we orbit the sun. What are the results of this collision? Scientists believe that the arms of the Milky Way appeared precisely because of this event, which happened about 900 million years ago. Just imagine its scale, let's say bigger. This is not the only collision of the mentioned galaxy with the Milky Way. The event has happened at least 3 times over the past 5 billion years, and that's not all. A 4th collision is expected soon. By the way, it's quite possible that one of these catastrophes gave birth to our solar system and ignited its main star. Was it easy for the orbital station to conduct this research? Not at all. Even though Earth's atmosphere didn't interfere with the telescope's ability to peer into the darkness of space, nebulae and stellar gas made it very difficult. If it's so difficult for us to study our own galaxy, then what can we say about more distant locations in the universe? It's especially hard to see anything closer to the center of the Milky Way because that's where the largest amount of matter accumulates. In general, our galaxy is an obstacle to studying other objects in the macrocosm. Scientists have come up with a term for this, the zone of avoidance. This sector represents the galactic plane of the Milky Way, a location where objects are cataloged the least completely. Astrophysicists are trying to overcome this obstacle in various ways to fill in the gaps. The situation can be compared to when you are in one room of a house, not knowing the layout of the entire building because the walls are in your way. In particular, X-ray methods are used to study the obscured area, and parallax measurements are also used to fill in the gaps in observations. However, this method isn't as accurate as we want for stars. Nevertheless, despite the difficulties, the Gaia Orbital Observatory has calculated the positional parameters of about 2 million stars in our galaxy with the highest precision. In particular, this was made possible by the design of the telescope, which is equipped with a number of innovative instruments. For example, special attention should be given to the enormous digital sensor with an extremely high resolution of 938 million pixels, which currently has no analogs. For sending data to Earth, antenna arrays are installed in the body of the spacecraft. Regular antennas were not used in this case due to the rotation of the telescope. A mechanical drive would inevitably complicate the monitoring process. Do you have any objections? Gaia has studied only 2 million stars. So why praise it if there are about 400 billion stars in the Milky Way? Don't judge too harshly, it's just the beginning. The data continues to be decoded, and gradually the map of our galaxy will become more accurate and expansive. It doesn't matter that the information is accumulating slowly, the main thing is that it's accurate. Finally, we've come to the reason why, at the beginning of the video, we spoke disrespectfully about the Milky Way, calling it a cosmic thug. Unfortunately, that's true. Our galaxy has not only periodically collided with its satellites, but has also absorbed rather large objects. One of these major collisions, followed by a merger, happened about 11 billion years ago. The event was so catastrophic that the disk of the Milky Way literally swelled. The galaxy was named Gaia Enceladus, and thanks to research, it is known that its stars mainly fill the halo of the Milky Way. This merger also gave our galaxy the characteristic bar located at its center. The Orbital Observatory found that at least 3 more star clusters were absorbed by the Milky Way at different stages of its existence, including Cetus, LMS, 1 Wukong, and Arjuna Sequoia. But one event stands out significantly from the orderly series of mergers. When did it happen, and what was it? About 8 billion years ago, the galaxy Pont had the misfortune of approaching the Milky Way. Do you think it was absorbed? No, it was even worse. The Milky Way simply tore Pont apart into millions of constellations. What other benefits has the Gaia Observatory brought to the world of science? By the way, the orbital telescope discovered several new satellite galaxies, one of which is Nasos 2. It is located about 450,000 light-years from the Sun, is similar in size to the large Magellanic Cloud, and is populated mainly by very ancient stars. However, it is unknown how long it will remain a satellite of the Milky Way because it is gradually moving away from it. Have you ever seen the Star Bridge? Videla's Orbital Station Telescope recorded stars moving from the small Magellanic Cloud to the large Magellanic Cloud. It really looks like a giant bridge stretching from one galaxy to another. Why did we remember the Gaia telescope mission right now? The thing is, on March 27, 2025, the Orbital Observatory was shut down. The good thing is that the telescope left a lot of data, about 500 terabytes in just one package. Obviously, it will take a long time to decode them. It's possible that among this information, there will be valuable data for science, or even some that could turn it upside down. Overall, the telescope's data will help predict how the Milky Way will behave in the future. The information obtained provides a lot of opportunities for various computer simulations. Gaia has expanded our knowledge about asteroid trajectories, and this directly affects the safety of people on Earth, because one of these flying rocks could one day visit our planet. In that case, humanity would face the same unfortunate fate as the extinct dinosaurs. It's definitely better to know about such a scenario in advance. It's noteworthy that the observatory, after analyzing about 150,000 asteroids, discovered satellites near them. This has significantly decoded and expanded our understanding of such objects, and At the very least doubles their number. Gaia also found a new black hole in the Milky Way's spirals, besides Sagittarius, and the one with the asterisk, located at the center of our galaxy. The object is 33 times more massive than the Sun and is much closer to Earth, only 2,000 light-years away from us, which is somewhat alarming. Everyone knows what consequences the proximity to this deadly vortex has brought. What was special about the telescope's mission? One of the most remarkable events was the discovery of the Radcliffe Wave. This is a huge structure stretching over 9,000 light-years, located within the boundaries of the Milky Way, and it looks like a smooth wave. It could be a star-forming region or a scar from a collision with a large galaxy. It is also suggested that the structure may be related to the influence of dark matter on space. At the moment, scientists don't know exactly how the Radcliffe Wave formed. There is a hypothesis that the Sun itself may have formed in one of these structures. The object was first discovered by the Gaia telescope because two-dimensional modeling did not allow it to be detected. By the way, most of the structures of the Gould Belt are located in this area, where there are bright, massive stars, mostly young ones. For scientists, the discovery of the Radcliffe Wave so close to Earth was a real surprise and a reason for deeper scientific research. What awaits astronomers after this mission ends? Will a new telescope replace the one that's retired? Will it go into well-deserved retirement? Yes, such a project is planned and will be called Gaia, near infrared, but it won't be launched anytime soon, at least not for another 20 years. The event is set for 2045, but considering the raw data collected over 10.5 years of operation by the first Gaia orbital station, scientists have no time to rest. They have a lot of work ahead decoding it, and humanity can expect a stream of news about the Milky Way. Don't you notice how the familiar reality is falling apart right now? I wonder if humanity will be hurt by its fragments. We will tell you which modern discoveries are encroaching on the holy of holies of astronomy. But do you want to hear it? According to the latest research conducted by senior lecturer in cosmology at the University of Portsmouth, Daniel J. Whalen and his team, it was unexpectedly discovered that water molecules appeared in the universe just 100-200 million years after the Big Bang. Is that even possible? That's even earlier than the formation of the first galaxies. How did the astrophysicists come to such conclusions? And why do we still believe that life on Earth is unique? Daniel Whalen and his team of specialists conducted numerous computer simulations, modeling the explosions of the first supernovae. After all, these catastrophic events were the first chemical factories producing heavy elements for the formation of water molecules. That is, water appeared in dense molecular clouds enriched with the products of supernova explosions. So it turns out that conditions suitable for life could have existed much earlier than previously thought. Moreover, the planet Zamali, that is, planetary embryos, could have formed around not very massive stars as early as 200 million years after the Big Bang. This is a real sensation because just half a century ago, such assumptions would have been considered true heresy and punished by exclusion from scientific circles. What the discovery means in practice is simply that habitable worlds could have existed as early as the dawn of the universe. But that's not all. In 2024, the galaxy Jade's JSZ14-0 was discovered. Not just anyone, but the James Webb Telescope made the discovery. At that time, the galaxy was the most distant known. Its redshift, a parameter indicating the distance of objects, corresponded to a time period of about 290 million years after the Big Bang. That is, after the universe began. Back then, it was about 2% of its current age, which proves this point. This once again indicates that astronomers do not fully interpret the characteristics of this ancient period correctly. What surprised scientists the most when they deciphered James Webb's data about this galaxy. First, its diameter was about 1,600 light-years, which is unexpectedly large for such an early era. Second, the mass of this galaxy is hundreds of millions of solar masses, which indicates prolonged and intense star formation occurring inside this object for at least several million years. Third, astronomers were puzzled by the brightness of the galaxy JADE's JSZ314-0. It turned out to be dazzling and did not meet the expectations based on traditional ideas about young galaxies. But there's more to the story. In March 2025, using the standard instruments of the Atacama Large Millimeter Submillimeter Array Telescope, oxygen was detected in the spectrum of that galaxy. This is a real sensation because this trace element has never been detected at such a distance before. That means the region and the object itself are chemically mature. The published information about this amazing discovery can be trusted also because oxygen was detected by independent groups of scientists, so it's neither a mistake nor a coincidence. Astrophysicists are usually tough, but even they couldn't resist a creative comparison. Aspirant of the Leiden Observatory in the Netherlands, Sander Schou, compared the amazing discovery to scientists finding a teenager where they expected to see infants. Against the backdrop of these discoveries, the thought arises about the possibility of life in the early universe. And the question comes up, where are the worlds that appeared long before ours? Could it be that none of them were inhabited by intelligent beings? What in that case is the solution to the Fermi paradox? Although even if life did exist in those ancient galaxies, for us it would most likely be completely alien and incomprehensible. Over such a long time, the entire universe could have been colonized multiple times. What stopped the ancient macrocosm inhabitants from doing so? Perhaps something suddenly destroyed them. In that case, it must have been some kind of global cataclysm. James Webb has a preliminary answer: ancient black holes. So, during another monitoring of the universe, the James Webb Space Telescope discovered something strange, and there was a lot of it. What exactly did James Webb see? He discovered in the deepest parts of the macrocosm, on the threshold of the birth of the universe, small red dots with diameters ranging from 100 to 500 light years. The dimensions are modest, but the object's monstrous nature remains unchanged. Later, when processing the data, it turned out that these were compact galaxies that appeared about 600 million years after the Big Bang. However, later on, the list of what these objects could be had to be significantly expanded. Their incredible density gives reason to assume that these are quasars, galactic nuclei with active supermassive black holes inside. Where do these conclusions come from? James Webb's infrared spectrograph detected broad emission lines characteristic of accretion disks around black holes. It's a kind of funnel made up of matter being consumed by the insatiable monster. Only one thing alerted the astronomers: the absence of X-ray radiation, which is always present during this process. However, this could be due to an extremely dense dust cloud blocking the detection of X-rays. What else amazed the experts was that astronomers were surprised by the incredible number of these little red dots in a small patch of the universe. Hundreds of them were found. By the way, in that same year, 2025, the mentioned Daniel Weiland was involved in studying this cosmic phenomenon. The study was published in Astronomy and Astrophysics. As a result of supercomputer simulations, astronomers concluded that Earth science has encountered an entirely new class of objects called baby quasars. These are galactic nuclei with young black holes that are actively absorbing material. Most likely, baby quasars are the precursors of supermassive galactic nuclei. This has been recorded for the first time. It's a vast field for research. Only one question remains. Is it possible that these puppet black holes sterilized life in the early universe? Could this be one of the solutions to the Fermi paradox? In any case, it's becoming harder and harder to pretend and put on a brave face. The scientific community is clearly at a loss. Too much is at stake. Decades of research, centuries of accumulated knowledge. the crumbling pillars of fundamental theories. And just as scientists began to recover from the shock, a new discovery awaited them in the spectrum of the galaxy Jades JS Z13-1, one of those very ancient red dots. Lyman alpha radiation was detected, and this was the last thing astronomers expected to see in such a distant location. The alpha waves of the mentioned spectrum are usually produced by young, hot stars in galaxies with active nuclei. But the problem lies elsewhere. In the early universe, space was filled with a dense hydrogen fog that actively scattered Lyman alpha waves. Then why do we see them so clearly? Why do the dazzlingly red dots blatantly defy our understanding of the early universe and display a spectrum that should be drowned out? In the thick fog, maybe the hydrogen fog never existed and is only a product of our scientists' imagination. An expressive viewer might object, does such a little thing really undermine the strength of our theories? Oh, it certainly does. The fact is, the fundamental theory of the origin and development of the universe is impossible without the era of recombination, which began about 380,000 years after the Big Bang. So what was happening during this challenging time? After the detonation of the singularity point, the universe was an incredibly hot place, filled with super dense plasma. Gradually, it expanded and cooled down, and protons, photons, and electrons combined to form hydrogen atoms. This process was called recombination, and it triggered the appearance of that very hydrogen fog, dense, thick, absorbing light in the ultraviolet range, making the universe completely opaque. By the way, it was during this period that the cosmic microwave background appeared and the relic radiation was formed, which we still detect to this day. After the era of recombination, according to widely accepted theories, came the Dark Ages, where the hydrogen fog still prevailed. In this fog, we are not supposed to observe objects in the Lyman alpha range, but we still do. And this is quite puzzling, because only in the era of reionization did the hydrogen fog finally dissipate. It was gradually driven away by the radiation from the newly formed stars, and the veil completely disappeared about 1 billion years after the Big Bang. How did scientists resolve this dilemma? Since the period of the hydrogen fog is a key evolutionary stage of the universe, it cannot be excluded from the fundamental equation. Without everything falling apart like a house of cards, astronomers suggest that the cosmic haze dissipated earlier than we think. Also, in light of newly discovered circumstances, there is a theory that the hydrogen fog disappeared in sudden and chaotic bursts, rather than gradually and evenly. In any case, we can't completely rule out entire epochs, so astronomers have to fit new information into old scientific concepts. One thing is clear: cosmologists have a lot of work ahead of them to revise existing models in order to include the new water data in the equation. Maybe you have some ideas about this. The global scientific community would be very grateful.